2.4 Venn diagrams with 3 sets and verification of equality of sets. So please take the time with your notes or in this video to read what each region stands for, but I will be breaking it down as we go through the examples, especially example 1. All right, example 1. Construct a Venn diagram for 3 sets. So our universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's all the counting numbers 1 through 12. And set A is 5, 9, 10, 12. Set B is 1, 2, 4, 5, 8, 9, 10. Set C is 1, 3, 5, 8, 9, 11. All right, so the universal set stands for everything that you can use. So this is like our bank of numbers, or like all the puzzle pieces in the puzzle. These are all the pieces that we can use. So to say a universal set using Venn diagram, just like in 2.3, is we draw our universal set box, draw a pretty big box, all right, and we label it our universal set. All right, we have 3 sets. We have set A, so we draw circle A. We have set B, so we draw circle B. And then we have set C, so we draw circle C. Alright, so the first thing we're going to do, and this is how you do all sets, just like when there's 2 sets A and B, you start in the middle, then work your way out. Alright, so the first thing we're going to do is start from the middle and work outward. And we're going to really ask ourselves is, what do they all have in common? Meaning, all A, B, and C, what do they have in common? So if we look at A, B, and C, they have 5. So we're going to put a 5 in the middle in region 5. And then they have a 9 in common. So 5 and 9 is what they have in common. So since we used those numbers already, let's go ahead and cancel them out everywhere, including the universal set, because you're telling the universal set, hey, I already wrote you down, I already used you, so I'm going to cancel you out. Our second step, we're going to ask ourselves, what do A and B have in common? That's going to be region 2, so what do A and B share? So if we look at A and B, they just share 10. So since we used it, let's go ahead and cancel it out everywhere that we see it, including the universal set. Step 3, what do A and C have in common? That's region 4. So looking at A and C, all we have left with A is 12. C does not have 12, so they have nothing in common, so we move on. Alright, next thing we're going to ask ourselves is, what do B and C have in common? And that is also region 6. So looking at B and C, they have 1 and 8 in common. So we're going to put 1 and 8 in region 6. So since we use them, we're going to go ahead and cancel them out everywhere we see them, including the universal set. So now that we did all of the union sets of AB, AC, and BC, now we're working on the individual sets A, B, and C. So now we're working on the complete outside of the regions that they share. So just circle A, just circle B, just circle C. So what we're going to ask ourselves for each is, what's left over in it? So now we're going to do region 1, so what's left over in A? If we look at A, the only thing left over is 12. So we're going to put that in A. Since we used it, we're going to cancel it out everywhere that we have it. All right, now we ask ourselves, what's left in region B, or in set B, that's region 3, so what's left over is 2 and 4. So since we use them, let's go ahead and cancel them out. And last but not least, we have set C. So that's the last one we have to answer to figure out what's left over in it. All right, now we're talking about region 7, so what's left over in C? The only thing we have left over in C is 3 and 11. Since we used them, let's go ahead and cancel them out. Now, our last step, because there's 8 regions, so there's going to be 8 steps. We have to go through each region as we go along. All right, our last step, our last region, region 8, we're going to ask ourselves what's left over in U. So if we look at our universal set, what we have left over is 6 and 7. So we put them on the outside in the box. Example 2, blood types. Human blood is classified typed according to the presence of or absence of the specific antigens A, B, and Rh in the red blood cells. Antigens are highly specified proteins and carbohydrates that will trigger the production of antibodies in the blood to fight infection. Blood containing the Rh antigen is labeled positive and a plus sign, while blood lacking the Rh antigen is labeled negative with the negative sign. Blood lacking both A and B antigens is called type O. We're going to sketch a Venn diagram with 3 sets A, B, and Rh and place each type of blood listed in the proper region. A person can only have one blood type. Alright, so it wants us to sketch a Venn diagram. So to do that, we're going to do our U, our universal box, alright, now it tells us each set. We have set A, we have blood type set B, and we have set RH, which is kind of like a type of blood type, not really. So we have our 3 types of what indicates our blood. So it told us that if it contains RH, it's labeled positive. So RH stands for positive. All right, now we each to the left, we want to put them on our diagram. We want to put each of those blood types inside of our Venn diagram. All right, so like always, we're going to start in the middle. So we're going to start right smack dab in the middle. What do they all have in common? So where that all meets, that's A, B positive. So in the middle is A, B positive. So since we used it, let's go ahead and cancel it out. Now we work our way out. So I'm going to go up into region 2. So that's where A, B meets. But that A, B here, it is not inside of the positive. So since it's not inside the positive circle, this is A, B negative. It told us that if it does not have RH, we label it negative. And since it's not inside the RH bubble, the RH set, that's negative. All right, now I'm going to go to region 5. So, region 4. So in region 4, that's where A meets RH. So where A meets RH, that's A positive. So we used A positive. Let's go ahead and cancel it out. We also used AB negative, so let's go ahead and cancel that out. All right, now we move on to region 6. I'm one off in my head today. So in region 6, that's where B and positive meet. So that's B positive. So we used B positive. Let's go ahead and get rid of it. All right, last but not least, let's talk about our outside core bubbles, just A, just B, just RH. So if you're just A, you're not inside the RH bubble. So you're just A positive or A negative. All right, if we're just in the B bubble, you're not in the RH. We're just talking about this region right here. In that region, it's not part of the plus, so that's B negative. Now we have just the RH bubble. So just the RH bubble, I'm talking about this region right here, that region, that has nothing to do with A or B. So what the heck is that? If it's not AB, it's called type O. So this is O, and since it's in the RH bubble, that's O positive. The last one we never talked about and we still have on our chart is O negative. So remember I told you, Dora the Explorer, I really want you to answer this. You don't have to say it out loud. I mean, bonus points if you do, hypothetical bonus points. But let's go ahead, and I want you to answer this while I ask it. It's not rhetorical, please answer it. So what do you think is going to go right here in our universal set? I hope you said O negative. I hope you said it. I hope you thought it. I hope that you were thinking of it. So O negative, O has nothing to do with A or B. Negative has nothing to do with RH. So we have O negative. Verification of equality of sets. To verify set statements are equal for any two sets selected, we use deductive reasoning with Venn diagrams. If both statements represent the same region of the Venn diagram, then the statements are true for all sets A and B. So now we're given sets, and we're going to figure out if I have these two sets, are they equal? They might look different, but let's see if they're equal. We're kind of saying, is 1/2 equal to 2/4? We know it is. They look different, but they're the same thing. So that's what we're doing, but now with sets. So we have two pieces of our set. We have A intersection B and the complement of that. Then we have complement A union complement B. So we have two pieces, the left side and the right side. So we have our left side. Let's bring it out. And then we have our right side. All right, so for our left side and right side, we're going to break it into set and region. All right, so we're going to pay attention to one side at a time. So our left side, that's broken down. There's a few pieces there. We have set A, we have set B, and then we have the intersection of them. And then we're going to bring it all together with our complement. All right, we're going to do the same thing for our right side. So for our right side, we have complement A, union, complement B. So the first piece we have is complement A. Then we have complement B. Then we bring it all together. And now for our region, well, we need a Venn diagram for that. That's going to help us to give our regions. So we only have two sets here, A and B. And let's number our regions. So we have 1, 2, 3, 4. All right, now we're going to list all the regions A are in. So looking at our gold A is in region 1 and region 2. B is region 2 and region 3. Now we want to do the intersection of that. So where do they meet? They meet in region 2. Now we need to do the complement of that. So all the regions that exist with two sets are 1, 2, 3, and 4. So if where they meet is region 2, I want to know what regions are not region 2. So that's 1, 3, 4. So this is what we're going to look at because that's our final answer in regions for A intersection B and the complement of that. Now we're going to do the same thing with our right side of our equation. So complement of A, what we're talking about is every region that's not in the A bubble. So every region that's not in set A is region 3 and region 4. We're going to do the same thing to complement B. So every region that's not B, that's 1 and 4. Now I want to union those two things. So if we union those two things, that gives us 1, 3, 4. Remember, you never write your numbers twice when you're representing a region. So we're going to look at this as our final answer. So complement A union complement B simplifies down to 1, 3, 4 in regions. So if we look at these two, 1, 3, 4, 1, 3, 4, they're the same. Since they're the same, that's what it means. If both statements represent the same regions of the Venn diagram, then the statements are true for all sets A and B. So this is equal because they're the same. Guess what? That's something called De Morgan's law. We just proved De Morgan's law right there. So we just proved a law before we even talked about it. So De Morgan's law is a pair of related theorems known as De Morgan's law, makes it possible to change statements and formulas into convenient forms. We're going to talk about De Morgan's law again in chapter 3 with something called logic and symbolic logic. It's really fascinating. But with sets, here is our law. So a law means no matter what, it's true every time. So the complement of A intersection B is always going to equal the complement of A union complement B. The complement of A union B is the same thing as complement A intersection complement B. You can, for my little bit of algebra people who like algebra, you can kind of treat that as a negative sign. So if you distribute it, A, that becomes complement A. We flip the sign in the middle because negative means flip. And then we distribute, we get B. So that's how I remember how to use De Morgan's law. I treat it like a negative. We can also do it with the bottom one. So if we distributed it, that's a fun word to say that probably doesn't exist. If we multiplied it out, it becomes complement A intersection complement B. All right, example 4, equality of sets. So we're doing the same thing as example 3, except now with 3 sets, so A, B, and C. All right, so determine whether A union B intersection C equals A union B intersecting with A union C. So let's just break each side down, and then we're going to break it down into all the pieces. So let's draw our Venn diagram, since we know we're going to need it to label our regions, because we just learned that in the previous example. We know we're going to have to draw a Venn diagram. All right, we drew our Venn diagram and we labeled all the regions. Now we're going to break each side down. All right, so our left side, we have A union B intersection C. So we're going to break that down into each set. And then we're going to break it down into each region. All right, so our first piece, starting from left to right, is A. Our second piece is B intersection C, because we can visually see that on the page. And then we're going to bring it all together. All right, so looking at A, everything in circle A, every number, that's 1, 2, 4, 5. All right, now we want to find the intersection of B and C. So where B and C meet. So B and C meet in 5 and 6. All right, now we want to union those two answers. So if we put them together, that's 1, 2, 4, 5, 6. So the above set, A union B intersection C, simplifies into regions into 1, 2, 4, 5, 6. Okay, so this is where I want you to pause the video and try doing this side right there that I underlined in blue. So pause it and try it. All right, I really hope you do it. I really hope. You gotta try it. What's great about it, like I always say, no one knows if you get it wrong. Because who's there? No one, right? So you should try it. There's no harm in it. And guess what? You're gonna get it wrong. You might get it right sometimes. You might get it wrong sometimes. You might get some of it right sometimes. It's okay. But guess what? No one knows but you. All right, let's do our second region. If you didn't pause it, pause it. Okay. All right, I gave you a second chance. Let's do it. All right, so our second part, we have A union B, intersection A union C. All right, let's break it down into each set, each piece, and then each region. All right, so each piece we have A union B. We can see that. We can see that on the picture. Then our next piece is A union C, and then we're going to bring it all together. All right, let's figure out where and what region A and B come together. So everything that A and B have in common. So all of A, all of B. So looking at all of A and all of B, that's 1, 2, 3, 4, 5, 6. Now we're looking at the union of A and C. So everything in A and everything in C. So everything in A and everything in C is 1, 2, 4, 5, 6, 7. Now we want to figure out where these two answers intersect. So they intersect at 1, 2, 4, 5, 6. So that's our simplified region answer. And if we look at the two, they're the same thing. Since they're the same thing, they are equal. But guess what? We can say this in a fancy way. You want to learn how to say that two pieces of sets are equal? I'll show you how to do it all fancy talk. So this is how we say two sets are equal in all fancy language and math talk. A union B intersection C equals A union B intersection A union C for all sets A, B, and C.